what we're going to do now is factor polynomials. So let's review a little bit on factoring. The first thing we always want to do on our factoring is find the greatest common factor. You always want to check to see if you have one of those. If you have two terms, we want to look to see if you have a difference of squares. And the other two we're going to do today. So these two we're going to learn today. So those are new, but the one in yellow is a review. If you have three terms, then we want to check for if it's a perfect trinomial, or what I call a trinomial riddle, is what two numbers multiply to give you the last number and add up to the middle number. And if you have more than three, we want to group things together. So today the new one is the difference, or the sum and difference of cubes. So we're going to find cubes in the problems we're going to do. So let's start with our first problem. So the first thing I want to do is find the greatest common factor. Well, there is one between the 16 and 54. It's a 2. And between the letters, the x is the only thing that's common, and its the lowest exponent is x. So I'm going to put a little brackets there. So that's the greatest common factor, and I'm going to factor that out. So this will become 8x cubed plus 27y cubed. And so what I have here is a sum of cubes, because 8 and 27 are cubes. And how you can find that is if you go in your calculator and press this, you will get 2. And if you go in your calculator and press the cube root of 27, you'll get 3. So that's how I know they're cube roots. If they don't come out evenly, they're not cube roots. So now I'm going to use this formula and do the cube root. So that means I have my 2x as my first factor. My first factors are my a and b. A are the cube roots of, and I'm looking at this part right here. So the cube root of that is 2 and x. That because 2x cubed gives us 8x cubed. So 2x, and then on the 27, that's 3y. So it's going to be a plus 3y. These are considered your a and your b in the formula. Now I can go ahead and finish the formula. So for a sum, I'm going to take a squared. So a squared is 2x squared. So 2x squared becomes 4x squared, because that's what 2x squared is. And then I want to do a subtraction sign, and then I multiply a and b. So 2x times 3y is 6xy. And then I want to cube or square my b. Well, my b is 3y, so when I square it, I get 9b, or 9x. Let me do that correctly here. You get 9y squared. So I have this completely factored now because I've done the cubed. That's this part right here. And I have my greatest common factor. So together, that's my answer. All right, let's look at our next problem here. Greatest common factor between this, well, the y's are common, but so is the 5. So if I factor that out, I'm going to get y cubed minus 64z cubed. So once I have that factored, I have my 5y as my first factor, but now I'm going to do the difference of cubes. So the cube root of y cubed is y. My cube root of 64z cubed is 4z. And so there is my first part of the formula. So this is my a and this is my b in the formula. So now I can finish it. So I square a, so that's y squared. But this time I'm going to have a plus sign in the difference. So I go plus times a times b. So y times minus 4 is minus, not minus. It's not a minus. It's just the numbers, y times 4z, which gives us 4yz. And then I square the last part, and that's going to be 16z squared. And so what I have is my cube. Once again, I want to highlight, there's my cube roots. This is my cube formula, and then I have my greatest common factor. Okay, to factor by grouping, we're going to group in even numbers. That means if I count terms, I have 1, 2, 3, 4, 5, 6. So I'm going to group them by 3. So I'm going to create 2 groups. And if it was 4, I would go 2 and 2. But I'm going to go 3 and 3. And then I'm going to factor each of these groups. So if I factor this, the first thing is my greatest common factor. So the greatest number that goes into 8, 4, 4 is 4. The letter that repeats in all of them is x, so I'm going to take out the x, but the a and the b and the c don't. So now when I factor that out, I get 2a plus b plus c So there's my first one. Then I'm gonna do the second one. 3 looks like we have a 3 and a y that's common. And so if I take out the 3y, I get 2a plus b plus c. And if you do this correctly, what's in the parentheses, so this part right here, should be the same numbers. They may be in different orders, but they should be the same numbers. And if they are, that becomes your first part of your answer. And then what's on the outside of the parentheses becomes your second part. So 4x plus 3y. So we group it, and then we take the greatest common factor, and whatever's in the parentheses is a factor, and what's outside the parentheses is your other factor put together. And there's your answer for the first one. Now, this last problem is a combination of everything we've been doing. So let's go through the process of what this is. So this is a difference of squares, because I have a difference in two terms. And so I have y cubed, fault. I have x cubed plus y cubed, and then I have x cubed minus y cubed. So by separating this into squares, that's the perfect square space, I now have cubes that I can go through the process of each of these. So I'm going to do this first one in red. So I have x plus y, and then that gets multiplied by squaring the first term, multiplying the terms in it, and since it's a plus, it's going to be a minus on this one, so x times y, and then plus y squared. There's the first one. The next one is x minus y times the x squared plus multiply the x and y, and then the y gets squared. It's y squared. So I just broke each of these down, and let me go ahead and just rewrite this one in blue so you can see how I broke down the cubes. So if this should have been x cubed minus y cubed. Okay, so there's my difference of squares, and then I broke down each of these. And so this is our factored answer that we have when we finish doing the squares and then the cubes. So we end up with just this as our answer.